All right, it's another exciting day in Algebra 2. Today we're going to look at properties of exponents and logarithms, starting with exponents. Quick review, your product rule. When you're multiplying like terms, you can add their exponents. A power rule, if you are raising a power to another power, you multiply those exponents. Power of a product rule is going to draw your attention to what does your exponent apply to. If you have a product in parentheses with the exponent on the outside, that indicates that your exponent applies to everything within your parentheses. If there are no parentheses, however, it would only apply to the term that it's touching. So in that example, there's no parentheses, so the m exponent only applies to b. Negative exponents, this just means you're on the wrong side of your fraction, so you would move to your numerator or denominator. Zero power rule, anything to the zero power is 1. Quotient rule, when you're dividing like terms, you can subtract their exponents. And then power of a product rule, again, if you had that fraction in parentheses with your exponent, that would tell you that it applies to your numerator and your denominator. And then fractional exponents are new, and we will address that separately on the second page of this set of notes. This first page is just going to look at those other rules that we just discussed. So starting here on the first one, if you don't have an exponent written, we're assuming that it has an exponent of 1. So I have negative 4 to the first times negative 4 to the third. That means I can add my exponents, and this will give me negative 4 to the fourth power. And now I know that this is going to give me a positive outcome because I have a negative times a negative times a negative times a negative. Well, negative times a negative is positive, so if I end up with the multiplication of two positives, I know my final outcome will be positive. And 4 to the fourth power is 256. Looking at question 2, this is my power rule. I have negative 3 squared to the third power. That means that I'm going to multiply my exponents, and I will get negative 3 to the sixth power. Circling back to kind of what we did on number 1 here, if I have a negative that I'm multiplying 6 times, what I will end up with is, again, a positive outcome. And the way that you can do that shortcut is if you have a negative input and your exponent is even, you will get a positive output. If your input is negative and your exponent is odd, you would get a negative output. And then 3 to the sixth power is 729. Moving on to 3, this is my power of a product. I have the parentheses here with the squared on the outside, so that means it is applying to everything. So I have to multiply those exponents on each term. And then again, y has no exponent there, so we're assuming it's to the first power. So this is going to be 3 to the fourth, x to the fourth, y squared. X and y are variables, so I can't do anything there to simplify this, but 3 to the fourth is a number, and it's 81. So this is going to be 81 x to the fourth, y squared. On the next one, I have m to the seventh times 1 over m to the fourth. That's the same thing as m to the seventh divided by m to the fourth, so I could use my quotient rule here and subtract my exponents to get a final result of m to the third. On 5, we have a couple things going on here. The first thing I'm going to do is consolidate my denominator using my product rule, which means I will add those exponents, and that will give me 8 to the 8th power. Now I can focus on my quotient rule and subtract my exponents. 9 minus 8 is 1, and anything to the first power is just itself. Moving on to 6, this is again power of a product, so I am going to raise everything inside here to the 0 power and multiply my exponents when necessary. So I'm going to end up with 2 to the 0, x to the 0, y to the 0. Well, anything to the 0 power is 1, so this is 1 times 1 times 1, which is 1. On 7, this is another product rule, and I don't know what y is, so I just am going to leave this as y plus 6 in my exponent. On 8, another product rule. Again, I'm going to add my exponents, and one of them is a fraction, which means I need to convert 5 to a fraction. And I can do that and rewrite it as 25 over 5 so that it has a common denominator with 3/5. So that gives me a final outcome of 28 over 5. So g to the 28 over 5 power is my final result, and this exponent is a fraction, and we will talk about what this really means on the next page. last two for this side. 3 squared times 3 to the x, that would be like 3 to the 2 plus x power. So if that's equivalent to 3 to the 10th, that means that 2 plus x has to equal 10. And I can solve for x as being 8. The next one is similar, except it's my quotient rule. If I have 3 to the y divided by 3 to the 4th, that means 3 to the y minus 4 is going to be equivalent to 3 to the 5th. So y minus 4 must equal 5, and therefore y is 9. All right, now we are going to look at those fractional exponents as promised. What this means when you have a fractional exponent is whatever your denominator is corresponds to a radical, and that tells you the index for your radical. So when we are just writing square root, what we are assuming is that the index is 2. When we have other numbers there, we know it's a cube root, fourth root, etc. Whatever that number is, that's the index of your radical, and that corresponds to the denominator of a fraction exponent. If you have a numerator, that's just a regular exponent, and your denominator corresponds to a radical. So what we're going to do next is practice going back and forth between radical and exponent form. So starting with square root of x, again, that means that my index is 2. So this is x to the 1/2 power. On the next one, this is cube root. My index is 3, so this is going to be to the 1/3 power. And both the 6 and the x are inside, so I need to put them in parentheses to clarify that the exponent applies to both of them. On c, I have the square root of x to the 5th power, so that means my denominator is 2 because it's a square root. And then because it's to the 5th power, that is going to be my numerator. So this is x to the 5/2 power, or 5/2, however you'd like to say it. And then on d, I have the cube root of 3x to the 4th power, so that means that my exponent is going to be to the 4/3. And both 3 and the x are part of that radical, so I need to put it in parentheses so we know my exponent applies to both parts. Okay, now we're going to do this the other way around. I'm going to start with an exponent and convert to a radical. If I have 1/3, that means it's the cube root of x. If I have 1/2, that means it's the square root of x. If I have 4/3, that means that it's going to be the cube root to the 4th power, and then the 7 and the x are going to go inside because I have parentheses there. Now with the 4, I have two options. I could put it on the outside like I did here, or I could put it on the inside of my radical, but we just need to make sure we're keeping parentheses around the 7x so we know the 4 applies to both. And then on d, I have 3x to the 2/3, so this is going to be another cube root of 3x, and we're squaring it so that 2 exponent can go on the outside or on the inside. Okay, this next one is kind of combining everything we talked about on the front side and this side. We are going to consolidate this into one term with a single exponent. So what that means is everything needs to be in exponential form. This first part is good, but I have a 5th root of x. So before I can combine, I need to rewrite that as an exponent. Well, that's just x to the 1/5. And then I still have x squared to the 1/5, and those two terms are being multiplied. So I need to take care of my power rule first. X squared to the 1/5 is going to give me x to the 2/5 because I multiply. Now I can use my product rule, and what I will do is add these two exponents. Luckily, they already have a common denominator, so I don't have extra work there. And what I will end up with x to the 3/5. Now, what we just want to do is find the value of a being that final exponent, and that is just to the 3/5. A is 3/5. Okay, our last part of this page is looking at our negative exponents. This, again, just means you're on the wrong side of the fraction. So on a, I have negative 4x to the negative 2. So to make this a positive exponent, I need to move it to my denominator. Now, this exponent only applies to the x because there are no parentheses. So negative 4 will remain in my numerator, and I will move x to the denominator where it now has an exponent of positive 2. On b, I have 3x to the negative 1. So again, there's no parentheses. This only applies to the x. So 3 will stay in my numerator, and x moves to the bottom, x to the 1. On the next part, I do now have parentheses, so this whole thing needs to move to my denominator, and I will now have this to the positive 2 power. And because I moved my entire term to the denominator, my numerator is just going to be 1. Okay, and then lastly, 5x to the negative 3, the whole thing is in parentheses, so the negative 3 applies to the whole piece. So that will move to the denominator, and I'll get an exponent of positive 3 now. Because I moved everything, my numerator is now just 1. And then this is my power of a product rule, so that will be 5 to the third x to the third. 5 to the third is 125. So I have 1 over 125x cubed as my final result there. All right, that wraps up our lesson on exponent properties. I will do the log properties in a separate video.